Okay, so 6.3, proving identities, T6. This is the outcome. And this is part one. So we're going to look at how to prove an identity. And basically what that means is that we're going to be manipulating both sides of the equation independently from each other. We're not going across. We're working on one side and then we're going down until they are identical. Okay, so here's some helpful hints. So you're going to rewrite all functions in terms of sine theta and cos theta. You're going to factor. You might have to multiply by 1, and that means that you create a multiple that is going to help you, a multiplier that's going to help you. So sine over sine or cos over cos or something like that. You're going to simplify, expand, multiply by the conjugate. So the conjugate, remember that where we had something where you've got 1 plus cos alpha, the conjugate of that is 1 minus cos alpha. We did this a lot in the grade 11 where we had, we wanted to rationalize the denominator. We multiplied by the conjugate, right? So for instance, if we have 1 minus sine x, what's the conjugate of that? 1 plus sine x. Okay. All right, so things to remember. Identities are different from equations. Keep the sides separate. We're going to draw a line down the center so that we keep it separate. Use the correct variable. So if the question starts with theta, make sure you're using theta all the way through. Don't flip it from one variable to the other. Use the variable that's given in the question. You're going to have the statements, left-hand side equals right-hand side. You could use LHS equals RHS. Show all work. Points are allocated for work. And don't invent new math. Don't think you're going to catch the marker or try to BS your way through by just kind of using some math-magic that isn't legit. Because it's, we usually find it and it's not in your favor. So make sure you can justify and it's legitimate math work that you're doing. Yeah. Okay, let's go. No, because what you can do, no. If the answer is right, you still don't get marks because you could easily just say, oh, sine theta on this side and then sine theta equals left hand equals right hand, blah, blah. It's not gonna go well. You're getting the marks for the procedure on each column that you're working through. Okay, although it is comical at times, and if you're just kind of throwing a Hail Mary. Okay, so let's have a look here. Example 1. So prove the following identities for all permissible values of the variable. Well, what's the simpler side? This is the simpler side, right? Which side is this? Left, right, right? Okay. So the left-hand side, let's start off with writing the left-hand side is equal to, and then I'm going to copy this. Sine x, secant x, cotangent x, all right? And then I'm just going to work on the left-hand side. I'm going to rewrite everything in terms of sine and cos. So sine over 1. And then what is secant x? It's 1 over cos. And then what about cotangent? That's 1 over tan, right? And it's sine over cos. So then this is going to be cos x over sine x. All right. And now we can reduce. This cos for this cos, this sine for this sine, and then we end up with 1 over 1, which is equal to 1, which is equal to the right-hand side. All right? Okay. let's have a look at this question. Okay. Here, I'm going to rewrite this. I'm going to do this question instead of that one there. So sine alpha.
I just started doing that one though.
Did you? Oh, that's too bad. Okay.
Is there an answer for that though? If I like continue it, will I be able to finish it?
Why don't you do it now then?
Okay. Sine alpha. All right. So now I want to have a look at this question because I want to look at this this stuff here. So what's our left-hand side?
The remaining hand side.
So this is sine alpha 1 minus cos alpha, right? Okay. Now, we need to work and figure out how to deal with this. So what we're going to do, there's not really much I could do right now. Okay, so I'm going to multiply by the conjugate. Okay, and the conjugate is 1 plus cos alpha.
You're welcome.
Now, I can't.
Wait, that wasn't anything to say. Bless you.
Yeah, you're supposed to say bless you when someone sneezes. Now,
You're welcome.
I can't just introduce a 1 plus cos theta, can I? No. What do I have to do if I want to introduce something new? I have to use the property of multiplying by 1. So if I want to multiply this 1 plus cos alpha, I have to create a 1. So this is my 1 that I'm creating, okay, because it reduces to the same thing. And then I could multiply my numerators through. Sine alpha cos alpha over, and then 1, you know what? I'm backing up. Oh my goodness. I'm backing up. You know why I'm going to back up?
You should have done the original question first.
No, because what I'm going to hope for is that I can cancel something out. So if I multiply these two denominators together, what should I end up getting? 1 minus cos squared alpha. Now, what can I replace 1 minus cos squared alpha with? With sine squared alpha. So I've got sine alpha, and then 1 plus cos alpha, and then sine squared alpha. So now you realize, do you see now why I backed up there? Because, so I replaced this here with sine squared alpha. And now this sine alpha reduces with one of these sine alphas, and what do I end up with? I end up with 1 plus cos alpha over sine alpha. And this is equal to the right-hand side. Now, technically, I should be working down, but I've run out of room on this page, so that's why I started working across. Okay. All right. So now for this, part C, what am I going to do with secant? I'm going to rewrite it as 1 over cos. I'm going to rewrite the tan as what? Sine over cos. I'm going to rewrite this cotangent as cos over sine. Okay, so let's see what happens. So left-hand side is 1 over cos, and then this is sine over cos plus cos over sine. And now I've got, oh, don't forget my x. Now I've got this that I have to deal with somehow. Okay, so if I need to add these two fractions together, well, I need to add these two fractions together. How am I going to approach that? How do I do? I need a common denominator. So what would be my common denominator now? So here I need to multiply a sine x over sine x, and then a cos x over cos x. So now I've got sine times cos as my common denominator. Okay, so far I've got 1 over cos x all over sine squared x plus cos squared x over sine x cos x. All right, now, do I notice an identity somewhere? Right here? What is that equal to? One sine x cos x. All right.
Oh, yeah.
This is 1.
Yeah.
Okay, so now this is 1 over cos x. It's a Pythagorean identity. Times, and then I'm going to flip this one because I'm going to multiply them, and then sine x cos x over 1, and then what do we do here? Cos and cos equals sine x equals right hand side. Beauty. Done.
Wow. Okay, wait, don't move it. Copy all this down.
Okay.
Thank you, ma'am.
So 1 over cos x is this numerator part right here, okay? And then this is dividing by 1 over sine x times cos x. And then in order to do the actual division, I multiply by the reciprocal. And then I wrote the reciprocal over here, and then I reduced. Okay? Yeah. This question? So I changed the sign here. Okay? Okay, so now in this question we have it set up a little nicer, where you've got your left-hand side and right-hand side blocked off from each other. So the left-hand side here is 1 minus cos squared theta, and the right-hand side here is cos squared theta tan squared theta. Okay. Now I'm going to make sure I have my equal sign on this side and work down. And I want to work it to somewhere where it looks nice. It's not too complicated. And then I'm going to pause, and then I'm going to go to this other side, to the right-hand side, and I'm going to see if I can work through it to make it look like this side here. Okay? Okay, let's do it and you'll see what I mean. So how can I alter 1 minus cos squared theta? What I need to do is I need to have my formula sheet in hand so that I can be aware of the identities that are around. So, 1 minus cos squared theta. So is there anywhere that I could see that, or are there any one of these that I could rearrange to get that?
Sine squared plus.
Ooh, this one here, right?
Yeah.
So what can I do? I can subtract my cos squared theta on both sides, and then I've got sine squared theta equals 1 minus cos squared theta. Okay, so that's this. Sine squared theta. Okay, I'm going to pause on this left-hand side, and I'm going to go and I'm going to see what I could do on the right-hand side. So this, I'm going to rewrite the tan theta as what? Sine squared theta over cos squared theta. What do you notice?
Oh man, that's brilliant.
Done.
Okay, so that's a nice, simple one to get our feet wet with.
Yeah.
Okay, so now we need to finish this off with this last statement. Left-hand side equals right-hand side. Okay, make sure you have that final statement there. Okay, let's have a look at this next one here. Kind of same idea. Okay, so rewrite your left-hand side, rewrite your right-hand side. Okay, and now for this, what are we going to do? Cos squared x, multiply by the reciprocal, sine x, cos x. Now what happens here? I have a cos squared here and I have a cos. I can reduce one of them out. I have cos x times sine x. Okay, now I'm going to pause here. And I'm going to go work on the right-hand side. Oh, but wait. My right-hand side looks like my left-hand side already, so I'm done.
Oh, this is fun, actually.
It is. Okay. All right. And the more you do, the more practice you get, the better they are, and the more fun they be, because it's just like solving a puzzle, figuring out how to get from one side to the other side in the best way or in the way that you seem fit. Okay. All right, now let's look at this one here. So the left-hand side is cos 4 theta minus sine 4 theta. And then this is 1 minus 2 sine squared theta. Okay, so work on a side that looks the more complicated, and I would say this looks more complicated. So if you notice, this is a difference of squares, so you can actually factor it so that it's cos squared theta minus sine squared theta, and then cos squared theta plus sine squared theta. Uh-oh, I went over the line. I should have started further out. Now, what do you notice about this here? Yeah, that equals 1. Okay, so this is equal to 1. So now this is cos squared theta minus sine squared theta. Okay, I need to somehow make this look more like this. Any ideas of what I can replace? Well, how can I rewrite cos squared theta? I want to keep it in terms of sine because my right-hand side is sine, right? So change the other guy, and the other guy in this case is cos. So change the cos, and how can I change it? I can use what? 1 minus sine squared theta. Okay, so now I've got 1 minus sine squared theta minus sine squared theta. What's that? 1 minus 2. Perfect. And so now that left-hand side equals right-hand side, and you're done. So not too bad. Just a couple things to remember. You need to make sure that you have that you're not making up the math, that you're actually doing real math, and that you're not trying to trick the marker, because the person marking will probably find the error. I will be looking, absolutely, I will. Every step has to follow. So we mark these line by line. Every previous step has to follow. If there is some erroneous math going on, then, well, that's unfortunate. Okay? And then the homework for the section is right there.
1 to 10.
Yeah. And then there's also some questions on the next page. So right here, you've got these questions, exercise 15. All right, it's right in your notebook. So these questions here.